In this video, we are going to be reviewing greatest common factor and least common multiple. First, we're going to be going over what exactly is a factor. So a factor is a word that I would use in everyday life. Literally, what it means is something that goes into something else. So like a factor of doing well on a test would be studying for it. Studying for the test is what goes into getting a good grade. The same is true for the definition of factor in math. A factor is a number that goes into another number. So for example, if I look at the number 10, I'm going to think about what numbers go into 10. So for example, 1 times 10 make 10. So I create this rainbow here to show that 1 times 10 are both factors of 10. Another factor, a pair of 10, would be 2 times 5. So I need to check each number, 1, 2, 3, 4, 5, 6, until I get to a number I've repeated in order to find all of the factors of this number. So I checked 1, I checked 2, now I'm going to check 3. Can I do 3 times anything to get 10? Nope, I can't. So, no 3. How about 4? 4 times anything to get 10? Nope, 4 does not work. Then how about 5? Oh, well I notice I've already written down 5 as a factor of 10 over here. When I get to a number I've already written down, then I know that I have found all of the factors of this number. So I can get rid of this 5. And making this rainbow here is how I find all of the factors of this number. A clue that I use to help me remember that when I'm looking for factors, I make the rainbow, is I think about Skittles. On Skittles commercials and ads, it always talks about taste the rainbow, see the rainbow, feel the rainbow. So when I see the word factor, the F in factor is my clue that I am going to feel the rainbow. I am going to make the rainbow, and that is how I find factors. So now we're going to move on to the next step and talk about greatest common factor. So greatest common factor, let's break down these 3 words first. So I have the word greatest, which I know means to be the biggest. I have common, so I think about things in common or things that are the same. And then factor, which we just talked about, are numbers that go into another number. So greatest common factor literally means the biggest number that goes into another number that is the same. So let's look at an example. The greatest common factor of 12 and 30. So what I'm going to do is find the factors of both 12 and 30. So the F, greatest common factor, reminds me that I'm going to feel the rainbow. So I'm going to make the factor rainbows for 12 and 30. So 12, I check 1, yep, 1 times 12. I check 2, yep, 2 times 6. I check 3, yes, 3 times 4. I check 4, oh, I'm noticing that I've already written down 4. So that tells me I'm done. I have already found all of the factors of 12. Next, I'm going to make the factor rainbow for 30. So I check 1, yes, 1 times 30. I check 2, yes, 2 times 15. I check 3, yes, 3 times 10. I check 4, nope, I can't do 4 times anything to get 30. All right, how about 5? Yeah, 5 times 6. Okay, how about 6? Oh, I've already written down 6. So that tells me that I am done. These are all of the factors of 30. So now next, I found the factors. Now I'm going to think about what are the factors in common between these two numbers. Well, they both have 1, they both have 2, they both have 3, not 4, not 5, but yes to 6, not 10, 12, 15, 30. All right, those are all of the factors in common between 12 and 30. So now my last step, I found the factors, I found the ones in common, so now I'm going to find the greatest one. Which one of these is the biggest number? Well, 6. So my greatest common factor of 12 and 30 is 6. Okay, now I have 3 example problems for you. Your job is to solve these on your own, remembering how we find greatest common factor. And so in a second, you'll pause the video, solve these 3 problems, and then when you have them figured out, you can play the video again to check your answers. So go ahead and pause the video now. Okay, so here are the answers that you should have gotten. The greatest common factor of 15 and 20 is 5. The greatest common factor of 20 and 40 is 20. And the greatest common factor of 19 and 28 is 1. So to solve each of these, I made factor rainbows for both numbers and then found the biggest one that's in common. It's really important that your factor rainbows look just like mine. So that means that you have found all of the factors of each number. Be sure to check 1, check 2, check 3, check 4, check 5, check every single number until you get to a number you've repeated. This is the way that you can be sure that you have found all of the factors so you didn't miss any. Now we are going to use what we learned about greatest common factor to answer some word problems. So here's some keywords that we would find in word problems that would give us a clue that we need to use greatest common factor to solve them. If you see the word greatest, that's a clue. That makes sense. Greatest, we're talking about greatest common factor. Biggest, or really any word that shows most, like the widest, the deepest. They're all words. Greatest means the biggest, the most. So that makes sense. We're looking for words that relate to this word greatest. So for example, here's a problem. A team has 35 bagels and 28 donuts that they're putting into boxes. What is the most number of boxes that they can make? So I'm looking for keywords and I see the word most. So I am going to circle it. So this word here, most, tells me that I'm going to use greatest common factor. So to solve this problem, I need to find the greatest common factor of 35 and 28. So I'll make my factor rainbows. I check 1, yes. I check 2, 2 times, nope, 35 is an odd number, so 2 does not work. I check 3, 3, nope, 3 does not work. I check 4, nope, 4 does not work either. Okay, let's check 5 now. Yes, 5 times 7. How about 6? Nope, 6 does not work. How about 7? Nope, now I'm back to a number I've already written down. So I am done then. So I have found all the factors of 35. I will do the same for 28. Check 1, yes. Check 2, yes. Check 3, nope, 3 does not work. Check 4, yes, 4 times 7. Check 5, nope, doesn't work. Whoops, just got rid of my 4 there. Check 6, nope, that doesn't work either. Now 7, I'm back to a number I've already written down, so I have found all of the factors of 28. Now I will find the ones that are in common. Okay, which one is my biggest? 7. So the greatest common factor of 35 and 28 is 7. So my answer to the problem is 7 boxes. Now here are 2 example word problems that you might see. So let's read the first one. Sarah has 16 red flowers and 24 yellow flowers. She wants to make bouquets with the same number of each type of flower in each bouquet. What is the greatest number of bouquets she can make? And then the next one. Fabric is sold in stores from bolts that are either 45 inches wide or 60 inches wide. What is the width of the widest strips of fabric you can cut from each bolt without wasting any of the fabric if each strip has the same width? So these 2 problems, your job is to find the key word that tells you how you're going to solve it, and then actually solve the problem to find the answer. Now, a note that I'm going to make is that you might not know, for example, what a bouquet is or what a bolt of fabric is. That's okay. You do not have to know what every single word in this problem means. What you need to do, though, is look in the question at the end of the word problem. What key word can you find in this question at the end? If you see a key word in there that tells you about greatest common factor, that's going to be your clue for you of how to solve it. So if you can find that key word to use greatest common factor, just find the greatest common factor of these 2 numbers. You don't have to know what each word in the whole word problem means. Okay, so you're going to solve this and then play the video when you have the answer to check your answers. So go ahead, pause the video, and solve these 2 problems now. So here are the answers that you should have gotten for these 2 word problems. So my keyword in this first problem is greatest. So I'm going to use greatest common factor. This F in greatest common factor tells me I'm going to feel the rainbow. So I need to make my 2 factor rainbows, find the common factors, and I get the greatest common factor is 8. In the next one, my keyword in this question at the end is widest. It's the biggest width, the most. So it tells me I'm going to use greatest common factor. This F factor tells me I'm going to feel the rainbow. So I make the rainbows, find my common factors, and the biggest one is 15. So my answers for these are 8 bouquets and 15 inches. Now we are going to move on to multiples. So first we're going to just talk about what is a multiple. So just like factors, multiple is a word that you would use in day-to-day life. For example, if I have all these little dots, I have multiple dots on the screen. I have more than one dot on the screen. So just like multiple in everyday life means more than one, multiple in math means more than one too. So for example, if I'm looking at multiples of 10, I could have 1 10, I could have 2 10s, 3 10s, 4 10s, 5 10s, 6 10s, 7 10s, and so on. I'm looking at many 10s, more than 1 10, multiple 10s. These are multiples. So now that we've talked about the meaning of the word multiple, more than one, we're going to talk about least common multiple. So let's break this apart too. So when I'm talking about least, that means the smallest. So smallest, common, things in common, things that are the same, and then multiple, more than one. So I'm talking about more than one number that is the same and it's the smallest one. So the smallest multiple of a number that is the same. So for example, we could talk about the least common multiple of 10 and 15. What I need to do is just like how in greatest common factor I found factors of both of these numbers, now when I'm talking about least common multiple, I'm going to find some multiples of these 2 numbers. So for 10, multiples of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I could keep going on for a really, really long time, forever. Usually I like to do about the first 10 multiples and see if I can find something in common, but there really is no magic number that you have to do. Okay, 15. I'm going to have 15, 30, 45, 60, 75, 90, 105, 120, 135, 150. Like I said, I could keep going on, but I'll just stop after the first 10 multiples. So let's see, which ones are in common? I have 30 in both, 60 in both, 90 in both, and those are the ones I have in common so far. But I'm going to look for the least, the smallest one in common. So which one of these numbers that I circled is the smallest? 30. So the least common multiple of 10 and 15 is 30. So now here are 3 example problems for you to try. So your job now is to find the least common multiple of 5 and 7, 12 and 24, and 2 and 19. So in a second you'll pause the video, solve the problems, then play the video when you have them figured out to check your answers. So go ahead, pause it now. These are the answers you should have had. The least common multiple of 5 and 7 is 35. The least common multiple of 12 and 24 is 24. There are a lot of common multiples of 12 and 24, but the least or the smallest one is 24. Least common multiple of 2 and 19 is 38. So after doing 10 multiples of 2, I noticed that there were no common multiples in the first 10 multiples of 19. So I kept going with the 2's until I found one that was the same as what I see over here in the multiples of 19. So in this case, the least common multiple of 2 and 19 is 38. So now, just like with greatest common factor, we are going to look at keywords for least common multiple in order to figure out how to solve word problems. So in word problems, we are going to look for keywords as well, and these are some words that tell us that we need to use least common multiple to solve the problem. If you see the word least, that's a clue you're going to use least common multiple, or smallest. Smallest is the same as least. Or first, together, again, when will be the next time? So if we were thinking about our list of multiples, we want the first pair of numbers that are the same, or the smallest numbers that are the same. So these would all make sense when we think about how to find least common multiple. So as we read our word problem, we are going to look for any of these keywords in the question at the end of the problem to see if we can figure out what to use. So Patty plants trees in rows of 10, while her friend Maria plants trees in rows of 15. If both friends plant the same number of trees, what is the smallest number of trees that each girl will plant? So in this question at the end, I'm noticing this keyword here, smallest. That is a keyword that tells me I need to use least common multiple to solve the problem. So I need to find the least common multiple of 10 and 15. So multiples of 10, 10, 20, 30, 40. All right, then multiples of 15. Now I'm going to look for the ones that are in common. So I have 30, 60, 90. So now I want the smallest one, and that would be 30. So my answer is 30, And the answer to the problem would be 30 trees. So now here are 3 word problems for you to try. So in a second you can pause the video, read the 3 questions, and see if you can find any clue words, any key words to tell you if we use least common multiple. If we do, then use the least common multiple to solve the problem to figure out the answer to each problem. So go ahead, pause the video, and play it when you have the answers. These are the answers that you should have had for the 3 problems. In our first problem, our key word is first. So we're looking for the first time that we can find a number in common in the multiples. So in this case, the first one, our least common multiple, is 60. So the answer is the 60th caller. In the second problem, our key word is together again. So we're looking at the time when it's together. It's the same amount at the same time. So in this case, the least common multiple is 90. So our answer to this one is 90 seconds. Then the last one, the key word in this question at the end of the problem is least. And so least tells me I need to use the least common multiple. So I list out my multiples, and the smallest one is in common is 72. So the least common multiple is 72, which means the answer to the problem is 72 hot dogs and buns. Now the last part of this video, I have 4 word problems. Now these are all mixed up. Some are least common multiple, some are greatest common factor. So your job is to read through the problems, see if you can find any keywords, then use that keyword to figure out, are you going to use least common multiple or greatest common factor, and then solve the problem. So in a second you'll pause the video, solve these 4 problems, then play the video and check your answers. Go ahead and pause the video now. Now here are the answers that you should have had. So in the first problem, our keyword is first. So we're looking for the first time that we find a multiple in common. So the least common multiple is what we will use. And in this case, 15 is the smallest multiple in common. So our answer to this first question is 15 minutes. The next one, our keyword is most. Tells me I'm going to use the greatest common factor. So factor, the F, tells me I'm going to feel the rainbow. So I made my factor rainbows for 72 and 64, found the factors in common, and I discovered that the biggest one in common is 8. So the answer to this question is 8 teams. In the next question, it's talking about as many boxes as possible. So this is referring to the most possible, or in other words, the greatest. So I will use the greatest common factor. This F reminds me to feel the rainbow for 28 and 36. Circle the factors in common, and I discover that my answer is 4 boxes. Then the last question, my keyword is least, tells me I'm going to use the least common multiple. So I find multiples of 20, multiples of 30, and find the smallest one in common, which in this case is 60. So my answer is 60 desserts. So this is all that we are going to have for the video on least common multiple and greatest common factor. Hopefully you have a better understanding of what these 2 terms are and how to solve problems using them. If you still have questions, go back, see any mistakes that you made on the practice problems, and see if you can fix your mistakes and figure out where you went wrong.